Right, we've talked a lot about temperature, but as we know, climate change is so much more than just global warming. It also affects our hydrologic cycle, right, where water goes on our planet. So what factors impact the hydrologic cycle? Well, it depends on the temperature, on wind, on precipitation, all that good stuff. So averaged over the mid-latitude land areas of the Northern Hemisphere, so where we're at, right, precipitation has likely increased since 1901. And that confidence becomes higher after 1951. And these graphs are showing you all around the world how precipitation has changed since 1900. And you can see that all over the world, it's a little sporadic, right? We're not saying every single place is like this, but from 30 degrees north to 60 degrees north, we do see that definite precipitation increase. Why do you think, though, that our confidence in this trend becomes more clear after 1950? Well, I can think of a few reasons. Better instrumentation, right? Maybe rather than just a couple data points once a day, we now have millions of data points every second of the day. So we become much more confident in that. We also have a longer trend, right? If you're looking at changes over just a decade or two, it's really hard to know what's a deviation from the normal. But the longer trend we have and the more data we have, the more confident we are in being able to say, oh, this is different than normal. All right, now these trends in annual precipitation over land are showing, again, that all over the world, things are a little bit different. It's not just that precipitation is increasing everywhere or decreasing everywhere. It's different depending on where you are on Earth. So I want you to look at this global map and think to yourself, what kind of trends are you noticing? Keeping in mind that blue means we're increasing in precipitation and brown and black means we are decreasing in precipitation. I'm going to zoom into the US to make this trend a little bit more obvious, but you might have noticed that wet areas are getting wetter and dry areas are getting drier. So the East Coast, where we already have a ton of rain, right, especially around the Gulf, that's getting a lot wetter. Whereas the Midwest and in the West, where it's already a desert, it's already very, very dry, it's getting even drier. And this is caused by an amplification of the water cycle and a northward shift of rain belts, right? So basically, we're just making the water cycle go into overdrive, where places that were already experiencing a lot of evaporation are experiencing more evaporation, and places that were already experiencing a lot of rainfall are getting even more rainfall. And again, we'll talk about exactly why a little later in the semester. So we know that it's very likely that the global heat and surface and, sorry, there's the thing covering up. I can't read it. Anyway, oh, there we go. Near, it says near. Okay, so it is very likely that global near surface and tropospheric air-specific humidity have increased since the 1970s. So not only are wet areas getting wetter in terms of rain, they're also getting wetter in terms of humidity, just because a hot air can hold more water vapor in it. And if you think to yourself, well, humidity, we know it sucks, it's gross, it makes it feel hotter, but like, what will it really impact? Why do we care? Again, I can think of a few things. Because humidity makes it feel hotter, we can actually have more heat stress in people and animals and plants because it's hotter or it feels hotter. It might also impact ecosystems, right? So a lot of ecosystems require at the time to dry out. A lot of bacteria, mold, things like that can grow in really hot, moist places. So here in Georgia, we might experience more black mold growth and things like that. Whereas before, the humidity might have stopped that. A lot of bugs like silverfish really, really like humid environments. So as before, a house might have not have had a silverfish problem. Well, now as it's getting more and more humid, we might see more and more silverfish living in our homes, which can degrade our infrastructure. So humidity can actually have a huge impact on our day-to-day lives. Right. Speaking of humidity and water in our atmosphere, let's talk about clouds. So clouds are really fascinating. While trends of clouds cover are consistent between independent data sets in certain regions, substantial ambiguity and therefore low confidence remains in the observations of global scale cloud variability and trends. So you're going to hear me talk this semester about a lot of things in climate that we are certain of, right? We are absolutely certain. Temperatures are increasing. Sea level is rising. The hydrologic cycle is amplifying. We are certain about all these things. But clouds, like clouds are something we really don't know much about. They're really ambiguous. So why is it important for us to understand how clouds interact with climate change? Well, we know that clouds play a role in trapping heat near the Earth's surface, but also reflecting heat back out into the atmosphere, depending on where that cloud is in the atmosphere, whether it's high or whether it's low. We also know that clouds are what cause rain, right? We know that clouds are what cause shade. We know that clouds are associated with extreme events. So not knowing much about clouds actually means that there is still a lot of unknowns about what's going to happen with future climate. Right. So speaking of extreme events, right, it's very likely that the number of cold days and nights have decreased and the number of warm days and nights have increased since about 1950. That means that our, right, so how might warmer nights impact the health of plants and animals? Thinking about that, right? If we have less cold nights and more warm nights, well, who cares, right? Who cares? Won't things just be able to sleep a little easier? And the answer to that is no. So a lot of plants and animals need relief, right? So maybe say the daytime, it's incredibly hot. It gets up to 90 degrees Fahrenheit. That puts a lot of stress on plant and animal physiology. But that's okay. They can survive that if at night they get some relief. If at night the temperatures go back down. So often, I've got strawberries at the house, and after a really warm day, my strawberries will just look pitiful. Like their leaves will be dark green and they'll be all droopy. But then I come back in the morning after a cold night and they've perked back up and they're totally fine, right? But if the night is also warm and they never get that relief, then they will die quicker, right? Same thing with animals, same thing with people, right? When there's a heat wave, people often don't die on the hottest day. People die after a string of very hot days and very hot nights because our body just gets no relief. All right. Continuing with extreme events. So it is likely that since about 1950, the number of heavy precipitation events over land has increased in more regions than it has decreased. So if you look at this graph, you'll see, again, since about 1970, 1980, we're getting more and more extreme one-day precipitation events, more and more extreme flooding events. And we know that confidence in the large-scale trends in storminess or storminess proxies over the last century is low, owing to inconsistencies between studies or lack of long-term data in some parts of the world, particularly the Southern Hemisphere, right? So this comes back to our, I know a lot of things about climate. We are very certain about a lot of things in climate, but there are some unknowns, being clouds and a lot of what's happening in the Southern Hemisphere.